Welcome to Train Signal. You're watching a lesson on TCP/IP protocols. Now, I will tell you, in this lesson, we're going to primarily just kind of go through a bunch of vocabulary. In other words, I have a list of TCP/IP protocols, and we're going to go through each one and, well, learn what they are. So the first protocol that I want to discuss with you is one called FTP. Now, FTP stands for the File Transfer Protocol, and I bet you'll never guess what this protocol is responsible for. Well, you know what? Maybe you will be able to guess it, because it's very obvious. I mean, the name, File Transfer Protocol, yeah, it provides connection-oriented file transfer between a client and a server. Now, I don't want you to be too hung up on the whole client and server thing. I mean, it does file transfer between systems. I mean, technically, if you're transferring a file from one system to another, well, the system where the file is being transferred from is the server, right? Because it's serving up the resource. And the computer that the file is being transferred to, well, that's the client, right? Because it's receiving that resource. But the idea here is that the file transfer protocol is, well, it's responsible for the transferring of files. Now, one little side note here is I will tell you that it was originally used to transfer files between Unix systems, but the reality is that in today's world, it's the most popular file transfer protocol on the internet, across the board. It doesn't matter what type of system you're using. Now, one other real important piece of information you have to know is that FTP uses TCP ports 20 and 21. All right, now to be more specific, I want to point out that it's TCP ports that it's using, and that's because I mentioned that it's providing connection-oriented file transfer. Okay, and we learned in the TCP/IP suite that TCP is used for connection-oriented communication. But TCP port 21 is used for control information, and TCP port 20 is used for the actual data transport. Now, the next protocol is similar in name. It's TFTP, which stands for the Trivial File Transfer Protocol. And this protocol is used for connectionless file transfer functions. Okay, so TFTP is a simple and small protocol, making it suitable for transferring small amounts of data. I mean, that's the whole idea here. It's a very simplistic, small, no-nonsense protocol, which makes it perfect for trivial or small quantities of data. Now, it's typically used for things like updating your devices, like routers and switches. Okay, so if you have certain routers and switches that have management capabilities, they have software built in, it's very small types of software, and again, that's where the whole trivial comes in. Trivial meaning small, inconsequential. Well, that small little bit of information very often is updated using TFTP. Or another example might be the transferring of data required to boot a diskless system over the network. Okay, so this is something that was big for a little while. You don't see as much of it. It seems to go in waves. It comes and goes as far as these diskless systems where you have a computer that doesn't even have a hard drive in it, and it actually is going to boot remotely off of another hard drive. TFTP is sometimes used for that. Now, the other main piece of information that I want you to definitely make sure you remember about TFTP is that it uses UDP port 69. Again, UDP is, we knew that already because it's connectionless communication. And then you have to remember port 69. Now, this next protocol is one that I think just about anybody and everybody out there has heard of or seen. And the reason why is because, I mean, let's be real, everybody's on the internet. And every time you go to the internet, when you open up a browser, you always see HTTP sitting up in the address bar. Okay? So HTTP stands for the Hypertext Transfer Protocol, and it was originally designed for transferring World Wide Web, right? www, right? That's what always follows HTTP. So transferring of these World Wide Web documents, and has been extended now to transfer all types of files, right? In other words, we all know, I mean, the real simple answer for what does HTTP do? Well, it allows for web browsing. Okay, so that's why I have here the most common use is transferring web pages between a web browser on the client, right? When you're sitting at your web browser, getting those web pages transferred from the web server out on the internet out to that web browser. Okay, so real short, real simple, HTTP used for web browsing. The other piece of information, as we're already seeing and we're going to continue to see as we go through this lesson, is that it uses TCP port 80 by default. Okay, and I say by default because you have the ability to force HTTP to work out on other ports. And I'm not going to go into detail about this because that is something that you would need a whole detailed lesson about. It has to do with security, and it has to do with sometimes if you want to have multiple websites on a single web server. Okay, but the main thing to remember is just associate TCP port 80 with HTTP. Now, along those same lines, we could talk about HTTPS, okay, which is the exact same protocol, except for that the S stands for the fact that some people say it stands for secure. Other people say it refers to the use of SSL, which stands for Secure Sockets Layer. Okay, so the bottom line is you're now sending encrypted data and is also used for authentication with the server. A great example that could be used, and again, I'm going to guess that you're probably already familiar with this. Most people are. If you were to buy something online, right? You go to the internet, you go to some kind of e-commerce site, meaning you want to purchase something from somebody across the internet, and you're going to use your credit card. Well, you don't want your credit card information just traveling out there for the world to see in plain text. So you're going to go to a secure web page, and the way you go to that secure web page is through the use of HTTPS. And again, when you're looking at the web browser, you should see this. If you ever are on a website and you're about to enter your credit card information and you don't see HTTPS, and there are other indicators in the browser, like a lock symbol will show up and things like that. If you don't see any of that, don't enter your credit card. You are not on a secure site, and your information can be seen by anybody who wants to grab hold of it. Now, the last piece of information you have to know about HTTPS is that it uses TCP port 443. And again, technically I'll say by default, because there are ways to force it to use other ports, but you need to associate HTTPS with port 443. Moving along, the next protocol is NTP, which is the Network Time Protocol. And this is used to provide accurate time synchronization by synchronizing the time of a computer to a reference time source. Now, those time sources could be an NTP server, a radio, or even like satellite receiver. Now, NTP is capable of synchronizing distributed clocks as accurate as to the nearest millisecond. So not a whole lot that I really want to go into in explaining all the ins and outs of NTP, other than knowing that time synchronization is very important when you're working in an enterprise environment. All of your systems must be in sync with one another. It's actually a requirement if you're working in a Microsoft network with Active Directory in order to log in. So if you picture a machine that you walked up to and you go to log in, you enter your username and password. In order for that login to successfully work, you must have time synchronization in place. NTP is the protocol that is used to make that all happen. This protocol uses UDP port 123. This is always one of my favorite protocols to remember the port number on because it's simple. It's 123. Okay, so it's UDP, so it's connectionless. It's not something that we need to worry about some kind of connection orientation. And it's port 123. Now, the next few protocols that we have here are all related in some capacity to working with email. The first one would be POP3, which stands for the Post Office Protocol. And this is used to retrieve email. Okay, so basically, you use it to go out there and grab email off of an email server. Now, one thing about POP3 is that it is used to access the inbox folder only, and by default, your POP3 clients will connect to TCP port 110. Whereas IMAP 4, IMAP standing for the Internet Message Access Protocol, is also used to retrieve email. Okay, so a lot of people look at POP3 and IMAP 4 and they say, well, what's the difference? Which one should I use? Well, IMAP 4 can be used to access all server-based messaging folders, thereby eliminating the need for a local repository. Now, to take this just a step further, I will tell you that with POP3, when you retrieve email from the inbox folder, okay, so you connect to the email server and you pull down the messages that are in the inbox folder, you're truly pulling them down, meaning you're taking them off the server and putting them on a local computer where you've configured this. That's why most email clients have a setting. So for instance, I use Outlook. In Outlook, whenever I set up access using POP3 to one of my email addresses, I will check a box that says leave a copy on the server. Because the problem that people run into is they will go ahead and pull the emails, the incoming emails in their inbox off of the server, and they'll now be on their local computer, and then they'll go to another computer and want to go ahead and access their email, but of course they can't because that email is gone. It's on a local computer. Whereas with IMAP 4, what you're doing is you're not actually downloading any information to the local computer. There's no local repository. It's still out on the server. You're just viewing it, so to speak. You're just getting access to it. And again, with IMAP 4, it's not just the inbox. You can look at the inbox, you can look at the sent mail, you can look at any folder that you want. Matter of fact, you can even create additional folders using IMAP 4. The one other piece of information about IMAP 4 is that it's TCP port 143. Okay, so POP3 is 110, IMAP 4 is 143. I will tell you that you may have seen POP3 or IMAP 4 setups where you don't use port 110 or 143. You may have seen ports 993 or 995 used, and that's because you're using the SSL version or the secure encrypted version of POP3 or IMAP 4. Now, I don't even have those ports listed here because I don't want you to worry about it. I don't believe that you would be tested on it if you are looking to pass Network Plus, and it's not a very common scenario, but I just thought I would mention it in case you've seen it. The other protocol that we're going to talk about here that has to do with mail is SMTP, which stands for the Simple Mail Transfer Protocol. And this is used for sending email. Okay, so whereas POP3 and IMAP 4 were used for retrieving email, SMTP is used for sending email. There's not a whole lot more I want to say about it other than it uses TCP port 25. And again, similar to what I told you about POP3 and IMAP 4, you may have seen an SMTP configuration where you use port 587, but again, that's because you're using SSL or a secure form of SMTP communication. But the main thing I want you to focus on is associating port 25 with SMTP. Now here we have DHCP, and I'm going to give you the really fast version of DHCP. I know I've done this in other lessons as well, and the reason I keep giving you kind of this abridged version is because there's an entire lesson that talks about nothing but DHCP that I have in this course for you. Okay, so if you're sick of hearing the generic version, I'll make this quick, and then you can just go watch the DHCP lesson. DHCP stands for the Dynamic Host Configuration Protocol. It's used for the assigning of dynamic IP addresses to devices on a network. That's it, okay? DHCP simplifies network administration by making it dynamic. Super simple. DHCP uses ports 67 and 68. Very important to know that. UDP ports 67 and 68. Not just because I've mentioned it with all the other protocols. You have to know these ports. You do. But I will tell you that more specifically, when we learn about the ins and outs of DHCP, we learn how DHCP won't function through a router by default, but there are routers that are capable of allowing DHCP to work from one side to the other. And part of how that happens is by knowing that DHCP uses UDP ports 67 and 68. Now, another protocol that I'm not going to go into detail on because there's an entire lesson for it is DNS. DNS stands for the Domain Naming System, and it's a standard name service that allows your computer to register and resolve domain names. Well, if that doesn't sound like a bunch of double talk, I don't know what does. That didn't explain anything. The bottom line is I will tell you that DNS is a naming system that is used by the internet. It's a hierarchical naming system. That's why on the internet you see things like www dot certain name dot certain suffix. We'll use trainsignal.com, for instance. There's an actual hierarchy to that. And we'll learn all about that hierarchy in the DNS lesson. But the short version is you start with just a dot, and then you end up branching out to .com. That's like the next level in the hierarchy. And then from there, you have trainsignal.com. And then from there, you have the individual systems within trainsignal.com. For instance, www. I'm going to leave it at that. I'm sorry if that still leaves you a little bit confused, but again, I have an entire lesson on DNS. The only other thing that I am going to share with you about DNS right now is that it uses TCP port 53 for zone transfers and UDP port 53 for lookups. Not only do we have this hierarchical naming system, but DNS is also used to help perform what's called name resolution, okay, where you have a system where you, as I like to refer to it as the stupid human, and I don't mean you are a stupid human, I mean I'm a stupid human too. Meaning we don't like to think of things in the form of IP addresses, right? You think of trainsignal.com or google.com or microsoft.com, right? You think of things that way. You don't think of the actual IP addresses that are tied with it. Well, DNS is a form of name to IP address resolution, and you can do name lookups. And so UDP port 53 is used for those lookups. And when I talk about zone transfers, that's where you have multiple DNS servers which are helping with this name resolution. And those servers will transfer their information back and forth from one to the other, doing what's called a zone transfer. And that's on TCP port 53. So the easy answer is just remember port 53 with DNS, but there is an official breakdown of where TCP is used and where UDP is used. The next protocol I have here is Telnet, and this is what's called a terminal emulation protocol. It allows remote access to a system. Telnet can also refer to software, which can be used by a client to remotely connect and configure operating systems and network devices. So what does that mean? It means that Telnet is both a protocol and a utility. But whether you're thinking about it as a protocol or whether you're thinking about it as the utility that, by the way, uses that protocol, the idea is when we say terminal emulation, it allows you to have this remote terminal connected to a system. And very often, that system might be a monitorless system, like a router or a switch. Okay, it may be a device. It could also mean a system. It could mean a literal computer system that you're connecting to, but it doesn't have to. Telnet is something that is not used as heavily today as it was in the past, but it's still out there. Okay, I can tell you, I use Telnet, I'd say within the last year or two. I've certainly used it to connect to a switch, okay, a managed switch. So just know that it is still out there, and know that Telnet uses TCP port 23. Now we have a protocol which is SSH, which is Secure Shell, which can be used to provide similar functionality to Telnet, but it's the secure version. Okay, it's much more secure. Telnet is definitely considered to be insecure because it uses username and password information in plain text. All right, I mean, there's nothing secure about Telnet. As you are connecting to that remote system, things are being transferred in a way that can be captured and viewed without much difficulty. That's part of why you don't see too much Telnet out there anymore. Telnet should be replaced with SSH. SSH employs encryption through the use of certificates, and it also does an extra form of authentication of the server to the client. Okay, now this is something that is possibly new to you, something that we haven't really talked about, the idea of having server authentication. Right? Typically we think of client authentication, right, where the client needs to give credentials to the server before it can get access to the resources. Well, here we're looking at one of, and there's more than one, but this is one of the ways where you have servers who have to authenticate themselves and prove that they really are the server that you think you're connecting to the client. SSH operates on TCP port 22. Now, another reason that things like both Telnet and SSH are somewhat things of the past, and again, it's more about Telnet being a thing of the past. SSH is still used. But one of the reasons that it doesn't have to be used as much is because of this thing called RDP, which stands for the Remote Desktop Protocol. Now, this is a proprietary protocol which was developed by Microsoft. Okay, so when I say that RDP is used more often, that's also on the assumption that you're working in a Microsoft environment. But the idea here is that it's this protocol which provides a user with a graphical interface to another computer. And it's, really what it sounds like. When we say it's the Remote Desktop Protocol, it's exactly what it is. It provides you with a remote desktop, meaning you can be on one computer and using RDP, you can look at the desktop of another computer, meaning it's like you're sitting at that other computer. It's like you literally have walked over to another computer and you start managing it. And that's how a lot of servers are being managed these days. The IT personnel, they don't hang out in the server room anymore. They sit at their desks and they use their own systems to RDP into the servers. So it's like they got up and walked into the server room, but they're still sitting at their desk. So this is pretty cool. And I will tell you that RDP uses TCP port 3389. So that's the port that you have to remember. The next protocol that we're going to take a look at here is SNMP, which stands for the Simple Network Management Protocol. And you'll never guess, but yeah, that's right. It's used for network management. And the way it basically works is that you have network devices that will act as what's called agents. Okay, you actually have these agents out there which are collecting information. And then you have SNMP management tools. Okay, so out on a server, you might have the SNMP manager, which will then get the information from those agents. Okay, so again, I'm not going to go into this whole long detailed explanation about SNMP. Now, there's a whole process involved with exactly how SNMP is set up, and I will tell you that a lot of it is proprietary, depending on what form of SNMP management utility you're using. Okay, so we're not going to worry about that too much right now. I just want you to understand the idea that overall, even though a lot of it's proprietary, you have this management system, and then you have these agents that are out collecting the data, and then there's a form of communication to where either certain triggers can be put in place where if an agent sees a certain amount of activity, it says, hey manager, you might want to know about this. And then there's the other form of communication where a manager can go out to an agent and say, hey, what's been going on lately? Okay, so that's just kind of give you the real basic gist of how it works. And the other piece of information, of course, is understanding that SNMP uses UDP port 161. Now here I have a couple of protocols that are typically related to things like voice over IP. Okay, if you think of voice over IP, something that's real big right now, or any kind of multimedia over IP, that's what these two protocols have to do with. And the first one is SIP, SIP, which stands for the Session Initiation Protocol, which is used to establish, modify, and terminate these multimedia sessions. Okay, when I talk about multimedia sessions or calls, again, we're talking about voice over IP, where we could be just talking about the audio, like you're making a phone call across the internet, or maybe a video conference call across the internet. Okay, it's those types of calls. The Session Initiation Protocol establishes, modifies, and terminates those sessions. Whereas RTP The real-time transport protocol provides end-to-end network transport functions suitable for the applications transmitting real-time data, like the audio or video simulation data. In other words, where SIP is establishing and terminating those sessions, RTP is used for the actual end-to-end data transmission. Okay, so I want you to remember the difference between those two, and they're both related to things like voice over IP. And now the last protocol we're going to talk about in this lesson is TLS, which stands for Transport Layer Security. And this is a protocol which is used for establishing a secure connection between a client and a server. TLS is capable of authenticating both the client and the server. Okay, so again, I mentioned before where we talked about server authentication. Well, this is used for mutual authentication, meaning it can be used to authenticate the client to the server, and it also is used for authenticating the server back to the client, which means you get a solid encrypted connection between the two. Now, some consider TLS to be a replacement for SSL. Right? We talked about SSL, Secure Sockets Layer, being used primarily with HTTP, right? HTTPS. There are some places where TLS is being used in place of SSL, although I don't know that I agree too much with that statement. I think SSL has come a long way, and that's why we really haven't seen it go away. We're still using SSL, and I don't know if there's ever going to be a point that TLS completely takes the place of it. But I thought I'd throw it out there because some do present it in that fashion. Okay, so I think that that's probably a long enough list of protocols for you to have to work on for right now. Okay, so that does bring us to the end of this lesson. And I will tell you that these are the primary protocols that are being used right now that you're going to want to be familiar with if you want to be successful working in today's networks. So with that, I will see you in the next lesson.